Hello everyone. Today I'll be talking to you about change detection in the Angular framework. So, does it work? Come on. I'm presenting myself. Sorry, a bit loud. I'm Matt. I come from France. A lot of people in the community know me by my nickname, Jean-Mesh. And I'm part of the Angular team as an open source contributor. Professionally, I'm a software engineer and consultant in Visio at a company in France and present in several countries in the world. So, what are we talking about today? The concept of change detection is actually the process through which Angular checks to see whether your application state has changed, and if it has changed, it will apply the updates into the DOM. Just to give you an idea what happens when Angular runs change detection. So every time you have a component, that's, for example, that's the generated code for a component. You will have two things that happen. First, the condition above is when you create the component, and the second time it's what happens every time your component gets updated. So every time change detection runs, it will run this code into your app. When we talk about change detection, we have this concept of a rendering tree. So you have your component, your app, that's represented by an application ref, and you have your tree down below. So every time you trigger some changes, it will refresh every component into your app, starting at the root. Reception is bad. Starting at the root, and then every component will get refreshed, like traversing the tree. That's really a tree traversal that we are doing every time we do change detection. This is the basics of how it works in Angular. So the question is, how is it actually scheduled? How does the framework determine it needs to get refreshed and update the DOM? The technology behind it, it's the famous or unfamous Zone.js that will give you that will allow the framework to know when you need to update the view. God damn it. So Zone.js is able to tell us when the app is what we call stable. So it means that nothing is pending, and you can render something that because something did happen somewhere. And this is done by doing what Zone.js provides is on microtask empty. So for those who are a bit JavaScript experts, you have what we call a microtask queue. That's a thing that's added into a queue that the JavaScript runtime needs to execute. So when it's empty, Angular knows there's nothing happening anymore. I can update the view. This is the basic idea behind the change detection done with Zone.js. So the zone-based scheduler will fire what we call application ref.tick. That's what we had at what I showed before at the top of our app. So from the top, a tick will trigger change detection down the whole tree. And this is done automatically, so you probably never call yourself application ref.tick. Okay, so the question is, so you saw the basic idea of how it works, and it's somehow costly. It's well optimized, but calling too much change detection will cost you performances. What I mean performances is if your code takes more than 16 milliseconds to render the whole app, you will have frame drops. 16 milliseconds is what it's needed to achieve the minimum of 50 hertz, so 50 images per second. So the question is, how do we optimize change detection? And this is something that's not completely new. It's what we call the OnPush change detection strategy. So OnPush will allow the framework to only run on some components the change detection. So by running less, we will have better performances. And the basic idea behind this is we are going to tell more specifically when a component is actually dirty. Hopla. So the component will be dirty when you use OnPush, when you change the reference on the input. The first implication here is that you will need to do what we call immutable data. So if you use immutable data, you will be able to use OnPush. The other case where we're going to mark a component as dirty is when you call explicitly mark for check. That's one of the function on the change detector ref, or it's also called by the async pipe. So every time you have a new value pushed onto your observable and it's listened by a sync pipe, it will mark your component as dirty. And the last case that's also known is every time you have an event that is sent and it is listened into your template. So every time you have those braces, for example, a click or a mouse move or whatever, it will mark your component as dirty. So every time one of these things happen, it will mark every component and its ancestor as dirty. And in those cases, OnPush will change detect your components. Let's go back to the tree we had before. Here I have a case where at the top I have still my application. I see on the left the components that are that use the default change detection strategy, and on the right I just added OnPush on the right to right component here. Perfect. So when you do that, you see that actually it will skip. But what happens? It should. Okay. So in this case, sorry, the black ones were the OnPush, and the with the orange square is marked as dirty. So when you see that the ones that are OnPush but not marked as dirty will be skipped by change detection. So here you see that we run less code. So we do not code all the rendering function as showed you at the beginning. We will only run them on the dirty components. And as you see, for example, if you here have a OnPush component, but the childs aren't OnPush, they will still be rendered because it reached the parent here. And so when we talk about change detection, we talk also about the responsibilities. So when change detection is triggered for a given view, a few things will happen. So the basic thing that change detection does is actually executing the template function. So it will also run what we call the lifecycle hooks. So ng update, ng on changes mainly, and the other hooks after content in it, etc., etc. It will also update all the queries. So when I talk about queries, it's the view children and the content children, which view children, view child, content children. So those will be updated every time change detection runs. And it will also update the host binding. So every time you use either host binding or the host attribute into the component decorator. And also it will run the two new hook functions that were introduced in v17, so after render and after next render. So all those 5 points are what change detection actually does. Not only the rendering, but also calling all the functions you see here. I don't know what happens. So I will show you a small demo. And now it's going to be a problem. Maybe that's a better idea. Nah. Oh no. Worse. Yeah, now it's better. So, okay, and now I will show you the small demo. It is a demo that was written several years ago that I updated for change detection. Here, you can see a live component tree of an app. It's really a demo app. Every time you will, for example, click, it will show you which component will be a change detected. So here I have in black the default change detection strategy. In pink, I have the OnPush. So you see that if I click on a default component here, it will only refresh the default components. In the case I click here, for example, an OnPush, you will see that it will mark all the parents as dirty. So like I said, click as an event that's listened. So when you click, you'll see that the parent get dirty and all the components that are default and the components that OnPush plus dirty get change detected. For example, you see that the one here on the right, laser doesn't work. So here on the right, if I click, you see that it won't run change detection on it. So the basic idea here is just to show that optimization is possible. But now back to the responsibilities. You have to know that when you run change detection, so when the framework runs it for you, you have to know that there are some principles we need to respect. And one of them is unidirectional data flow. So it means that data flows from top to bottom. If you change something higher than you, so in the upper component from a component down, you will have an issue. So a component down the tree should never alter the rendering of one of its ancestors. And what happens if you do that? Do you know what happens if you change some data in a component that is used in the parent? For everyone that has ever used Angular, you will get, sorry, I don't know what the animation doesn't work. Because I'm not. Okay. I didn't start. Much better. So here, NG0100, the most famous infamous error everyone has ever had in Angular. So every time you change some data that is already used by a parent, you will have this infamous expression change after it has been checked. So it means that a component changed something that was already rendered by the parent. And like you see, haha. So I will give you an example, basic example of a form where these kind of things happen. So you know that when you build forms, actually the data doesn't come from the parent, it comes from the DOM itself. So what will happen is that you will have an impact on other fields when you modify them. So basic example, let's take a form that just shows a status, first input gives you forbidden characters, and down you just the field that you want to fill. So here, if ever I have a forbidden character in my value, I will display invalid at the top. Basically, the code would look like that. It's just custom directives, etc. So we have a model that either display valid or invalid. We've got an input that's just with a reference, and down we've got the model directive and the illegal directive. Basic idea. And what happens if you do that? We will have this same error. And why? Why that? Because you see that first we have invalid, the status, I mean, and down you have the field that actually influence the value. And I can show you this directly in the demo. Here I have this example. If I start writing something, and for example, here I have my string, and I change the forbidden character, you see that here I just entered a string, and my form became valid. So why is it valid? My code is correct somehow, but you see that we have this error that has been triggered. And this error happens because it means that it already rendered valid, so the status, but then it evaluated the forbidden characters. So the status was updated by the reading of the input field. And this is what we would call the bidirectional data flow. It means that data comes from the up, but also from something that down the stream. So this doesn't work. This doesn't work, and we will see how we can address this issue. So, can we fix it? The answer is yes, there is a possibility to fix that. So how do we fix expression changed? And here is the basic idea of the directives I was talking about. You see that it just uses an input string, and we have the validator which checks everything. The idea here is just to say, hey, whenever I update the value, so I set the value, just run change detection. You know, if you've been doing some Angular, you know that calling, for example, set input will fix a lot of rendering issues. So set input here will trigger a new change detection, and it will fix visually the issue that I showed you. So for example, if I add it here, so it can be set input, set timeout, but it can also be things like promise.resolve or something like queue microtask. Sorry. So here, if I do this, you will see that we can enter, for example, math, and I just add here, and you see that now the status is correct. I still have the issue, the warning down in the console, but we know that because change detection ran at the time I rerun when I set the inputs on the forbidden characters, it will update then the status again to the right value. Zoom a bit. So like that. So the basic idea is that we can fix this kind of issue by rerunning manually the change detection. And you have to know that, so the three functions that will rerun for you change detection, either set timeout, promise resolve, or queue microtask. And you have to know that this is what the framer does itself. Here I've got the example of the ng model directive, and you can see that's code from the code base, from the Angular code base that I show you right here, and you see that they do the same thing in the code base. We use here a promise to rerun change detection to be sure that the rendering is correct. So it's not particularly dirty because it's the way we can fix this issue that from changing the model from downstream actually, and not from above. So there is a second issue with the code I showed you, and it's OnPush. In the case I have here another, it's here. I've got here a component that takes the same model that was updated here. So I have the model which gives me the status, and you will see that if again I type this and I have the invalid that's updated, but the validity component down here doesn't update. It doesn't update, do you know why? So it uses OnPush, and you can see that I'm just passing the model directly. Any idea why it doesn't update? You know, then tell us. Exactly, same reference. So because we have the same reference, Angular was told to not update this component. So it means that we have changed some values, but the component wasn't updated. So using OnPush has some consequences. We need to know that if we change something, we need to use immutability. So here, we just broke something by using OnPush, and this is one of the cases that's kind of hard. So when we do that, we have to know that it can break. So the question the team was asking itself a few years back: can we fix all of this? Can we make this easier? How can we improve developer experience in those cases? And the answer is signals. Signals is what will help the framework understand the state and understand the changes. Here, give you what the model I had would look like with signals. So I have a value, that's the value that was entered, so where I put always my name. I got my set of validators. The valid is a computed property that just checks the validators against the value. And as you can see, there was also a function that was just adding a validator. And when you use signals, you invoke them directly into the template. So here, I don't pass anymore a value, I pass an invoked signal. And here what it does, by doing this, I tell Angular that right here I'm consuming a value, the valid value from the model. So here it's the computed I'm consuming. So the framework will know here I'm using this data. It means that every time I'll be using, changing the model, I know Angular will know that it will need here to update the component. And same here, in the case of the illegal directive, you will just read the values and you will read in the validator. So the concept behind signals is having a signal graph. A signal graph is just a hierarchy of dependencies. Here we had what we call producers. So a signal is a producer. It produces a value that will be provided to one or several consumers. So here the two values we have, it's on one side the model value, and on the other side the illegal string. And those producers will be consumed by the computed property. So the computed here becomes a consumer and consumes the model and the value just to know if it's valid or not. But a consumer can also be a producer for someone else. And here this is what happens. The computed becomes a producer for the template. And you see that here down you have the template becomes a consumer of the computed. So here we see that we have a basic hierarchy of a signal graph with consumers, producers, and end consumers. Just so you know, the template is what we call a always live consumer. So it means that it will always update every time something, it will update every time the signal changes. Because signals in itself are lazy. They will only be evaluated if there are some changes. So what's interesting here is that with Signal, Angular will understand what changes. Angular understand the signal graph. And thanks to this, the framework is able to understand what they will need to change. These are improvements that have been introduced in V17 to improve performances into the change detection process. So meet the traversal nodes. So now I have the same app with in black the OnPush components, and you will see that, for example, I will mark a signal dirty in one of the components that consumes it here. So here the component is dirty, and it will mark the parents as traversal. When a parent is traversal, it means that it will still go down the tree, but it won't change detect them. So in this case, I run change detection, start from the top, application ref, first component, okay, change detected. The default change detection runs still normally. Here, I skip the first OnPush because it's not dirty, and you see here, it's not dirty, but it will still be reached because it has been marked as traversal. And here, what happens is that change detection will not run. It will only run on the dirty one and its children. And for example, in this case here, the other child is on push, so it was not marked as dirty, so it will not be change detected. So here we have, with signals, an improved change detection run, so it will only update the components that are dirty. Just to, for the comparison, before we had a more global approach to change detection, so every time one component was just dirty but not signal dirty, every parent, every ancestor was marked also as dirty. So the difference here that you will only update the components that have been dirty. And here, this is what I would call a local change detection, or more, let's say, a global. It's still global, it still starts at the top, it still will update the default strategy components, but it will only update the dirty ones that have been marked dirty by the signals. And this is one of the improvements that has been introduced even before we have signal components. Because the main change we expect with signal components that change detection won't start at the top of the app, but only change the components that have been dirtied by the signals. And I can show this again into the demo. So here, example, when I click this component, you will see that it will change detect so almost everything, because the parent are marked as dirty, as you can see. But if here I just update the signals in this component only, you will see I will uncheck this the automatic clearing. You will see that here I will. So first, when you update a signal does not trigger directly change detection. It only does when the framework has when the micro task queue is empty. So for example, when you do whatever event. So if I trigger it, you will see here that all the components that were previously change detected now are now not, and only the one that has been dirty here is being change detected. So it means that we have a local change detection this way. But also, I can show you what this also means, is because Angular knows when something has been changed, we are now able also to do the same with the case of NGO 100, so expression changed. So here I have exactly the same form, but implemented with signals. So if now I write the same, you will see that I don't get any error anymore. You see only change detection. And here I have a case that shows you that with signals, you will have automatically uh, bi-directional data flow possible without any error. So you can change data at the bottom, you can change it at the top. Angular will just handle it for you to refresh all the components without throwing any error, without having any issues on the rendering. Because it knows, it understands what changed and where it changed. So if you update something, you can, it will update parents, for example, because the data was changed by the rendering of children. And this is one of the major improvements that Signal will bring you, giving you a structure, a data structure that has a hierarchy, that has links between consumers and producers, will help the framework know when what to re-render. So this is the first idea I want to share with you. Second one, I wanted to talk about Zoneless. Zoneless, like I said, Zone.js is at the heart of the framework for doing change detection. But everyone that has been using Angular knows that there are some performance issues with Zone.js. For example, you want to integrate a graph library into your app. You know that you can have some major performance issues because the graph calls some patched APIs by Zone.js. So about Zoneless, the question is, how can removing Zone.js improve the developer experience, the performance, everything around Angular? So how does Zoneless address the challenges that Angular knows today? And removing Zone will or should address several points. So we have to know that Zone.js has a bundle size and an initialization overhead. Zone.js is 30 kilobytes of data, 30 kilobytes that are eagerly loaded with your app that you cannot subtract. You need it to run it. So if you can remove Zone.js, you just remove code that's 30 kilobytes, and that's actually kind of long to start. If you do a Lighthouse inspection, you will see that one of the issues is actually Zone.js for the bootstrap of your app. So removing it would improve your Lighthouse scores. But also, Zone.js is known, like I said, for example, in graph situations, to cause too many rounds of change detection. So it prefers to be on the safe side, and with Zone.js, change detection runs almost as much as possible, just to be safe that everything is rendered on your app. Removing Zone.js will improve the developer experience and the velocity. So the behavior can be confusing when you use Zone.js, when you end up outside the zone. There are some cases where you aren't anymore in the zone. For example, some APIs that are not patched by default, etc. Also, Zone.js makes the stack trace a mess. Have you ever tried to read the stack trace with Zone.js? So much lines just related to it, it makes it hardly understandable. So it would also improve those stack traces. And also, it can happen that the patching of the APIs by Zone.js can conflict with other libraries. So this would also help. And one last thing that you need to know is that Zone.js for promises can only patch the then method. It cannot patch async await functions. So what the framework does for you in the CLI, it just patches using a Babel plugin and replaces every async await you have in your code with the old then. So it introduces some boilerplate code more, and it's not great. So it also works for the team to maintain everything with Zone.js. So in the case we drop Zone.js, we will need a new scheduler because Zone.js was our scheduler. So the framework will implement some new functionalities with what we call a new zoneless scheduler, where somewhere the framework will notify the scheduler to say, hey, I know that you need to run change detection for me. And basically the idea that the team went right now is we have a prototype that the team has been testing that's based on racing two functions of the browser, either yes, I have it there. It's a set timeout with 0 milliseconds, and it also uses request animation frame. So once the browser runs one of these two functions, and the framework notifies the schedule that we need to change something, it will run the changes action for you. Basically, that's the idea of how the scheduler works. As like I said, you have a notify methods that's called but whatever feature in the framework, and it will run something if there is something pending from the framework side. So you need to know that Zoneless is not only about scheduling, because scheduling is one part, but there are also other things. There is about stability. When you do, for example, server-side rendering, the server-side part needs to know when the app is ready to just send the HTML generated to the client. And it's based on knowing if the application is stable. Your application, if you have, for example, a pending request or a pending interval or a pending timeout, this will make your application unstable. So we will need to know when the application will be stable or not. We use stability also in the framework for hydration, to know when the application has finished all with treatment. Hydration will do some cleanup, and this needs to run only when the app is stable. Also, if you want to do some changes, for example, you want to load a library when the DOM is finally rendered, you want to do this once the app is considered stable. And also, in the case of testing, when you want to check the generated nodes, for example, if you run into a unit test that needs to render something, you will check that only after the application is stable. So these are the challenges that the team will need to address by going zoneless. So the cases where I said when the app is unstable. So when you do some navigation, when you do use defer, when you do some request, etc. After CD has been scheduled, so the app, until the change detection has been executed, your app will stay unstable. So, and also there is whatever task you would like to make your app unstable for whatever reason, you will need to tell the framework that that your app is unstable. Currently, there is no possibility to do that, but the developer should be able to report whenever the app is unstable. Right now, we have an internal class that's not exposed yet, but something should be in the future. It will tell that something is currently happening. That's what we do server-side when we do some HTTP requests, for example. And this will be exposed through, for example, the application ref is stable. So we'll know if your application is stable or not, but you should soon be able to tell when it is. So that's one of the challenges that the framework needs to address so that people can do fully zoneless apps. So with Zone, we had what we called a global state, global knowledge, global change detection. With going zoneless and with the new signals, and like I showed you, the signal graph, we will be able to handle things more locally. We will be able to do things more optimized. So running less for better performances, this will be brought by local change detection. And this is the goal for the performance that team has set, improving everything by making things more local, by dropping also Zone. So this is something that's been actively working on. Like I showed you, you can have some local change detection right now in v17 by running signals into your app and still being in a Zone full app. So this is the basic idea that I wanted to show you today about how change detection actually works right now and what are the challenges for the future and all the improvements that are being working on. I think I have a few minutes for some questions. If some of you, I got 3 minutes, if some of you have a question. And Thomas has now a microphone for you if you want.
Thank you very much, Matthew. Like Matthew is a member of the team, and he will be coming to speak at SGConf in 2 weeks. So pretty lucky to have him.
Yeah,
Be
so
sure to catch him up after the talk because he knows everything about Angular.
So yeah, if you have more a general question around Angular about other features, I can try to answer them. Or if you have some question I can bring up to the team, I can also do that. So you can reach me after if you want.
Questions? Okay.
Thank you, everyone.